Okay, we're going to look at Horner's algorithm, synthetic division, also known as short division. So as opposed to doing long division, which we've done in earlier videos, if you recall, we divided x plus 3 into x squared minus 6x minus 27, and we got x minus 9 with a remainder of 0. You can go back to my other long division of polynomials video if you don't recall. But we're going to do the same thing, but using a Horner's algorithm or synthetic division, also known as short division, and get the same result. And it's actually a much quicker, easier way. When doing synthetic division, you take your divisor and set it equal to 0, and then use that root value, which in this case is -3. You can only use this algorithm with linear factors. Well, linear factors, they can only be x plus 3. There can't be any x squareds or cubes or something like that. So then I take this -3, and typically you write it in a little division symbol flipped and turned around. And then across the top you write the coefficients of each term of your dividend, which in this case are 1, -6, and -27. If there are terms that are missing, you have to substitute them. You have to squeeze in a 0 term value, or synthetic division won't work. So in this case, we have 1, -6, and -27. Synthetic division works, it's just an algorithm, works the following way. The first step you do is you take the number in front and slide it down. You then take the -3, multiply it by that term here, write it right there. So -3 times 1 is -3. You then just add these two values and slide it down. So therefore you get -9. I'm going to erase. Again, we take this -3. I'm going to use the red pen again, and do -3 and multiply it by this guy here, or write the result right there. In this case, I get 27. I then add these terms and write the result below it. So in this case, I get 0. I didn't want to do that in red. So notice that I didn't have to change the signs like I did when I was doing long divisions. I just combined the two terms that were vertical to each other. And you should notice that I do have the actual answer. 1 and -9 are the coefficients or the terms of this binomial right here. And how do I know that? Well, I'm taking a quadratic, dividing it by a linear. So if I have a second degree divided by a first degree, my result should be a first degree. So 2 minus 1 is a first degree. So now my result is x minus 9, where this is my last term, is my remainder. So we've just done synthetic division, which is a much quicker way of doing long division. Again, you can only do synthetic division if your divisor is a linear factor. X plus 3, x minus 7, 2x minus 1, that's fine. You can do synthetic division with that. Okay, so let's look at another example. Okay, so we're going to do synthetic division again, and my divisor is 2x minus 1, so we have to set it equal to 0, and I should get 2x is equal to 1, so x is a half, so my divisor with synthetic division is going to be a half. And then I need to write out all the coefficients of each term. Well, since I don't have an x cubed term, I need to write 0x cubed in there. So I get 4, 0, -3, 3, and -2. So the first step with synthetic division is this number comes down. I don't know why I just made that noise, sorry. And then now I multiply my divisor root number times that number there. I write the result right there. So a half times 4 is 2. I then add these two terms. Why is that the wrong color? I add these two terms and write the result below it, which in this case is 2. Again, I take this number, multiply it by that number, or write the result right there. So a half times 2 is equal to 1. I add these two terms and write the result below it. So in this case, I get -2. I then multiply the half times the negative 2, write the result right there, and that is equal to negative 1. I add these two terms and write the result below it, so 3 minus 1 is equal to 2. I then multiply the half times the 2, write the result there. Half times 2 is 1. I combine the vertical terms and write the solution below it, so negative 2 plus 1 is negative 1. So now, since I took a fourth degree polynomial, divided it by a linear, or a first degree polynomial, so 4 minus 1 is 3. So this is a quartic. This is now a cubic. So my answer is 4x cubed plus 2x squared minus 2x plus 2 with a remainder of negative 1. And if you look back in my video on division of polynomials, this is the same result that we got right here. Here's one more example of synthetic division. Again, the root value of this linear divisor is 3, so I put a 3 in the corner. There's an x squared term that it's missing, so I do 2, 0, negative 4, negative 1. And the first thing I do is I bring down the 2, and then I multiply the 3 times the 2, write the result right there. I get 6. I then add these two and write the result below it. In this case I get 6. Oops, I didn't want that to be green. I then take the 3, multiply it by the 6, write the result right there. That gives me 18. I combine these and write the result below it. I get 14. I do 3 times 14, write the result right there. I believe that is 42. Combine like terms. I add these two terms and write the result below it, which is 41. Since this is a linear, again, we can only use synthetic division, short division, Horner's algorithm with a linear divisor. We wrote it as 3. Since it's a linear into a cubic, our result is a quadratic. So my answer is 2x squared, 6x plus 14, with a remainder of 41. So my quotient, when x minus 3 is divided into my dividend of 2x cubed minus 4x minus 1, is this quadratic here with a remainder of 41. Obviously, x minus 3 is not a factor of this term right here. And we could have verified that by just taking 3, evaluating it at this function, and we would get 41. Okay, this is just a little breakdown of how synthetic or Horner's algorithm works. First off, I just want to take this function here and evaluate it at 2, and we're going to simulate dividing x minus 2 into this polynomial here using synthetic division in a second. But the first thing I want to do is I just want to take 2 and plug it into this function here. It's kind of ugly because it's 4 times 2 cubed minus 3 times 2 squared plus 2 minus 4. In order to do this, I need to use a bunch of powers. So I need to know 2 cubed and 2 squared, which is kind of annoying if I have bigger numbers than I need to plug in here. Let's just actually figure out what that would be. So here's my polynomial I've already plugged in here. Let me clear this out. And if I plug in 2, I should get a remainder of 18. So that means this is equal to 18. Using Horner's algorithm, if you recall back in the previous example, we were able to determine when a function value is just by using synthetic division. We were able to, the remainder that we got was always the function value when we had the divisor dividing into the function. So Horner's algorithm, I'm just going to rewrite, using Horner's algorithm, I'm going to get to Horner's algorithm. Let's just rewrite this term right here, where I'm going to take the greatest common factor out of the first 3 terms. So I'm going to take an x out. I get 4x squared minus 3x plus 1 minus 4. And then I'm going to take the greatest common factor out of the next pair of terms. So f of x is equal to x times x times 4x minus 3 plus 1 minus 4. So notice that this term, this function, and this function are the same, except this one has powers, and this one doesn't have any powers. It's just multiplication and subtraction and addition. So this is how Horner's algorithm or synthetic division actually works. This is a horizontal representation of synthetic division, and we're going to do a vertical representation in a second. So this is the basis for Horner's algorithm. So let's evaluate f of 2. So f of 2, using the above example, would be 2 times 2 times 4 times 2 minus 3 plus 1 minus 4. So using please excuse my dear Aunt Sally, the first thing I'm going to do is multiply these two. So I get f of 2 is equal to 2 times 8 minus 3 plus 1 minus 4. Again, please excuse my dear Aunt Sally says handle those two, so 8 minus 3, so we get f of 2 is equal to 2 times 5 plus 1 minus 4. So now I'm going to multiply the 2 and the 5. I get f of 2 is 2 times 10 plus 1 minus 4. Add these two. I get f of 2 is equal to 2 times 11 minus 4. So finally I get f of 2 is equal to 22 minus 4, which is 18, which is what we got here. This was a little annoying to do because we had to do raising to the third power. We were able to do this with little effort because it was just multiplication and addition and subtraction. So it just makes it a little bit easier. So let's see if we can connect what I just did to synthetic division. So let's set up synthetic division. Since my divisor is x minus 2, I'm going to put the little 2 in the corner. And my coefficients of my polynomial, which are written above, but I have a supplemental notes on the side here. So negative 3 plus x minus 4. So let me just highlight this piece right here, and this 22 minus 4. Okay. I made a mistake. I don't know why I have an x there. Okay, first thing in synthetic division, I bring the 4 down. I do 2 times 4, which is equal to 8. 2 times 4, which is equal to 8. I do 8 minus 3, which is 5. 2 times 5, 2 times 5, which is 10. I add 1 to it, I get 11. 2 times 11 is 22. 22 minus 4 is 18. My result is 4x squared plus 5x plus 11 with a remainder of 18. And notice that when I did synthetic division, when I did this nested multiplication, which was just a strange way of factoring the polynomial, that the multiplication and addition that I needed to do in Horner's algorithm or synthetic division was done the same thing, was the same operations that I did here and all these highlighted pieces here, and got the same result. So whoever came up with this, Mr. Horner, he noticed this pattern and was able to extract it out into a two-dimensional piece, which is much easier to handle than this one is right here. So that's just where synthetic division or Horner's algorithm comes from. You're just supposed to kind of appreciate that. Okay, that's it.